Right. Welcome back to the Starknet Basecamp. So this is our third session of the Starknet Basecamp Kampala. And in this session, we are going to be looking at a very crucial component of Rust programming language. This is what mostly differentiates Rust. And if you grasp it well, then you will appreciate and know how to deal with it and how to grow in it. So as always, the Starknet Basecamp is aimed at onboarding developers to Starknet, both those that have been developing elsewhere and those that are new to development in the Web3 ecosystem. So we are going for 2 months, and this is our third session, both remote and physical over a weekend. So for the remote, we always here on Monday, Wednesday, and Friday, 8 p.m. East African time. During this, we can chat, you can have Q&A, quizzes, and assignments. So there are very many topics that are going to be covered during these Basecamp sessions. I think we have already covered the general introduction to Starknet, fundamentals of Rust, and we are on the second fundamentals of Rust, I think, and also advanced a bit. So the next time we shall, I think, complete with the Rust programming language. That will be enough for you to get comfortable with learning Cairo. So what does the Basecamp aim to do? Those that will graduate in the Basecamp will have an SPOK minted for them, and that's Starknet proof of kudos. Participants, we hope to have a hackathon to win prizes for those that will attend, and more things like applying for grants and joining the Starknet Kampala team to further educate and bring others in the ecosystem. So for you to be considered an attendee, you must have attended more than a quarter of our live classes. To be a graduate, you should have attended more than half of our sessions and also have a score of greater than 50%. Then we have those creme de la creme, those who show a lot of enthusiasm for the ecosystem. You should have attended more than half of our classes, and you should have scored more than 80% from the questions. Yes. So today is 19th. This was recorded on 17th, but that's fine. Okay. So we are going to the second part of the fundamentals of Rust. And today I'm going to be mainly talking about ownership and much more. But the entire topic today is going to be about ownership, and hopefully come out of this with a very good knowledge about it. So as we've said, hopefully my screen is clear. Is my screen being shared?
Yes, it is.
All right. So in Rust, we talked about this thing called ownership briefly.
I have an inquiry.
Yes.
So earlier on in the lesson the previous lesson, you stated that it would be preferable to use Mac OS or Linux.
Yes.
Now the link that you gave us for Rust, there is a portion of it that has like a playground.
Yes.
Would it be is it okay to be working with the playground as a person finds the necessary adjustments to switch to Linux, or
yes.
It is
totally fine, and I think that's the best advice, because you need to practice, most especially with these lectures that we have, since they are hands-on. You need to see what we are talking about, and then So
Thank you.
okay. Is my screen clear? Or I should increase the font size? Alright, so how do we create a new folder? So let me want to be in Basecamp 01. So we are in Basecamp 01, and this is where we are going to create the new project for today. So I'm going to make a directory. You can either make a directory from here or come here and then create a folder, and yeah. So make directory, and this is too big, I think. Make directory, ownership, detailed. So the directory comes here, or the folder, and then in the folder you can then so I can change into I can change into ownership, and then I'll create a Rust program. So cargo new. So the other time we looked at mainly at this, and we looked at being in scope, going out of scope. We looked at things a bit. We looked at the ownership rules, and then variable scope, where you need to have this. That's a recap. So the string type, I think we can start with that and then build on that. So the string type. So I've created my cargo new event. Cargo new session 3. Just call it session 3. Yeah, so created here I have session 3, and then src. So this is where my main is. Is my screen visible?
Yes.
Okay, thank you so much. So we started by saying you can have a string. Let me say let s be assigned to hi. So when you want to understand this, first is when I assign s to hi, this hi is immutable. What I mean is by immutable is that one, it is stored on a stack, and a stack stores a static memory, that we always have s. So when we want to have maybe if you have this, can be also the same as maybe n, which is being assigned to, let me say, an integer 5. But then what if we want to have a string that we can change? So let me say we want to change hi to hello Basecamp or something. So this now brings in a new concept. Yes, and this concept, maybe if I print this, cargo run. have to cd into session 3 and then cargo, can be cargo build or cargo run. Yeah, so this will print it, but let's say want to change s to another variable. So in this case we don't use this string literal, we use the string type. So we can have probably let me put it down here. Let s1 be assigned to, so string from, yeah, so use this string from I. So this means that this will carry this and put it on a heap. But what will this mean? Actually, let me explain it with this diagram. That for a stack you have for a stack you have a pointer pointing to a specific memory. When you assign, okay, I think I've missed. When we assign s to this, so this string becomes something that can be changed, and this being assigned to a heap means that you can now have the liberty to maybe increase that data or remove or add something. So if I say, so how do we make it like how do we make it being able to be changed? We can make, maybe say let mute. So we talked about mutation. Let mute s be this. I think I've missed something. So we want to look at how Rust deals with data allocated to the heap and explain how Rust knows when to clean up. So we are taking this scenario. By muting this, so let me add on something with push str. So push str there. Then if I print, so when I put here mute and then use this push to add something to this will return an error. Okay, let me clear this. So cargo run. So this returns an error because s cannot be mutated, or this s is just a string literal. If I want to, and this means that this high is stored in a stack. So yesterday we said that accessing variables or values on a stack is quick because we have a defined storage, but a heap will have a dynamic storage. So this cannot be acted on. That's method not found. Push that str. Yeah. So instead, if you want to push, then we can have this string type. So you say s1 dot push str and we have high 5. So warning session 3, this is just a warning because help remove this mute since it is not even required. So one of the things that this compiler does is that it will help you. Here, let me also add in S1. It will help you also S1 and N. It will help you also debug your code. Cargo run. High there 5. So high is S. High there is this S1. So this S1 is stored in a heap. This is stored on a stack, and this is stored on a stack. And I'll be letting you know why we are doing this. Yeah, because as long as you know the mechanism of heaping and stacking, then you'll be good with Rust. So this is what we call memory and allocation. In case a string literal knows the content to compile, so in case a string literal we know wants to compile at compile time, it cannot be adjusted. So this is a string literal. Let me literal. So at compile time we shall know the memory for this. This we shall have just a memory for it, allocated for it in a heap. This will be in a stack. So this is heap. Yeah, that's why we can push. Even if we put mute here, we cannot push string to this because it is a literal. Yeah, I think I can have strained that enough. And that same thing has a big way on how Rust works or performs. You need to have always something in your mind that tells you whether it is a heap or a string. And as we go on, we are going to be seeing like different examples, how these bring changes, how we do garbage collection, because garbage collection is done on a heap. So once you have something that is stored in a heap, it is an entire new sort of ecosystem that involves how garbage is collected and referencing. Okay. So I think I can say this. So this shows when you have data that is stored on a stack. So PTR stands for the data. A length is the length of the data. In this term, it is 5, and the capacity is the total amount of storage allocated to the stack by the allocator. Okay. So I think we can have another example. So let's say you have let S1 be assigned to string from let me just say hello. And then we want to have S2 being assigned to S1. So what would this, for example, if we print S2, we said that so S1 and S2 can be assigned to So that means that this S2 is assigned to the data in S1, but this data is assigned on a heap. What happens in such a scenario? Does this S2 make a copy of the heap, or what does it do? Okay, maybe before we go to this, let me have something easy. So let X be assigned to maybe 7, 8, and let Y be assigned to X. So maybe we print X and Y. Okay. So in case we started from a point that you didn't get, I encourage you to watch the previous tutorial, the previous session that we had. So if I run this, you see that X and Y is fine. Why? Because X, this is stored on a stack, so Y makes a copy of that value, but because makes another copy because it knows the exact storage that this takes. Yeah. But then let's say now you have S2 that we all know that is stored on a heap, and then you assign S1 that is stored in a heap, and then you assign S2 to S1. Yesterday we talked about a pointer that points to the heap. So the pointer that points to this heap is stored in a stack because it is static. So this pointer is the one that will direct the program on where the data is stored. So what really happens here is that S2 just stores the pointer to this, to S1. I would have let me see where I can. So I think this is the very thing. So when we have, instead of S2 making another S2 like this and then points to this, what the program does is that S2 just also just stores a pointer, this pointer to this to where the data is. Yes. So if you've understood this, then you'll find out that if I print S1 and S2, I'm going to get an error. So I get an error, which I expected. Why? Okay, let's first go back. So when we assign S1 to S2, the string data is copied, meaning we copy the pointer, the length and the capacity that are on the stack. Copy the pointer, the length of this, and the capacity. The capacity is the total memory that was allocated to the heap by the allocator. The length is the total memory occupied by the data. You don't want to leave anything. So instead of having pointing to the data itself, we just copy the pointer. But then this act, so this act will cause an issue of having a scenario whereby if we move out of scope, for example, if 1 runs out of scope and then S2 runs out of scope, there can be an error. Yeah. So for us to prevent this error, when we declare S2 to be assigned to S1, S1 is moved to S2. So S1 moves to S2. I think that is it. So this is small s. Now when S1 moves to S2, S1 will no longer be accessible. Okay. So I can maybe further explain it from the diagram that we saw. Since we said that when a variable goes out of scope, Rust automatically calls the drop function and cleans up the heap memory for the variable. There's a problem where the data pointers point to the same location. So when S1 and S2 go out of scope, as both try to free the same memory, so it is called a double free error. So that one, Rust prevents it. That's why when you develop more with Rust, the compiler will always like sort of help you. But sometimes if you don't know these small things, then you find it hard. If it is stored on a stack, this is perfectly fine. But if it is stored on a heap, and we know that string type is stored on a heap, then we must be very careful in the way we do things. So to ensure security and prevention of such an error, after let S1 be assigned to S2, Rust considers S1 as no longer valid. That's when you try to use S1 after assigning it to S2, it will not work. So here, let me just remove S1. And once I run it, it's perfectly fine because S1 has been moved into S2. So in case we want to access S1, what do we do? So we go to, I think what I'm just going to do is to be leaving this. We go to variables and data interaction with the clone. So we start using the clone method whereby we are going to just clone the variable, make a clone, make a shallow copy or a copy of the variable. And how do we do this? So with my same, I'll leave these just for our revision. If you need also these files, I can provide them. I think I will provide them. So for us to access S1 again, we are going to have just a copy, a clone of S1. So let's S2. Yes, I think this one, S1 is cloned to S2. And then we can print. So if in case now we print, so both S1 and S2 can be printed. And the reason is we have just made a copy. So what we have done is in this diagram, we've made S1 like this and a copy of this to put into S2 instead of having this. Yeah. So actually this is what we have done, and S2 is here, a clone. So that means that this can be printed, or the code can be run. So when you find, like, sometimes you find these errors as you move, hello, so, and then you're asking where is the error happening or what happened. It is in terms of memory management, that's where most of the trouble comes in. Okay, so when we go back to, when you look at ownership of functions, this is a mechanism of passing ownership and functions. Yes, so we are going step by step, but of course, yeah, with a clear intention. So ownership and functions. So the mechanics of passing a value to a function are similar to those when assigning a value to a variable. Passing a variable to a function will move or copy just as assignment does. So we have seen that. Now, in case we take it to functions, it is the same thing. Are we popping or pushing to a stack, or we are allocating to a heap? It's always the same mindset. Okay. Should I just continue here? No, let me just... So this thing of ownership is what causes a lot of chaos. I'm writing the right code, it is behaving badly, but it's all about that. So you have to always have a mindset. Is this a stack? Is this a heap? And if it is a heap, how is my variable out of scope? If it is a stack, when does my value go out of scope? Okay. We can start with our string. So we want to look at ownership of functions. So maybe I can call a function here, takes ownership, and passing s1. So also, if being created means that this s1 is coming into scope, and here takes ownership of s1. So it implies that s1's value moves into the function. What does this mean? So when this value that is stored in s1 moves into, takes ownership into this function that maybe we can have here, we can have takes ownership into just that function. We can roughly just have it there. That means that this s1 has moved now into this. So if I print s1 here, or if I access s1 here, it will not work. Yet if that was a stack, it would have worked. Okay, let's continue. Maybe I can add on okay, let me add it here, and it's no longer valid. Valid here. So that means that in case I use a s1 here, maybe let me do my best. That maybe print ln s1 course, if I haven't, okay, maybe let me just try to print that and see the error. So this will bring, of course, an error. Text ownership expected. Okay, so there is an error for could not session 3 due to one previous error. So there is an error for this text ownership. Maybe we first work on this. So so this is expected to receive a string. So I can say maybe some string is some string or of type string, and then we'll return something. So for us to show a return, we use this. If we want a return, but since it's just giving us, we may not return anything. Okay. So probably we can print this. So yeah, this is now the error I was talking about. That this print here, using S1 here, will bring an error because S1 will no longer be available. Why? In the heap, when we give S1 to ownership, because we said that functions work in the same way as it was with variables, this S1 is moved to text ownership function, and if it is moved, then we cannot access it here. So that's why that brings an error. So if I clear that up and run without accessing it down there, okay, I think this is fn. So success. Let me try to do this. So this is the error. You cannot access S1 here. Okay, we can take this a bit further. Hopefully we are on the same page. Let's take a scenario where we have a variable that is stored on a stack. So 5 is stored on a stack, and we are going to assign it to maybe makes copy or copy, let me say copy of 5 of x. So we're going to assign this x to a function. We're going to call a function and then assign x. So at this time x is brought into scope. And then here it is not moved. Yes, so this is value does not move. No. It would move into a function, but since it is it's an I32, it's a copy. Let me put this here. So this thing that suggests. So since it is I32, it's just makes a copy. So that means that we can use it afterwards. Okay, so here you can say even after copying it, putting it in this function, so I can have it printed here and will not have an error. Yet for the heap I'll have an error. So let me define that function for copy, and then maybe just do something with it. This is I can say given number, it's an I32, and then yeah, let's print the given number. Yeah, so given number. Okay, so this is perfect, it runs perfect. Yet if the data was stored on a heap like this string, this would bring an error. Maybe I can say to 7. This is what would have caused the error. So let me put this out. So 7. So if I bring this back, of course an error will be gotten. Yet if I perform that same thing on variable that is stored on a method, that on a variable that is stored on a stack, you don't have. So the error is because of this. Okay, I think that has been gotten. If not, you need to look into it. So this is how you do your programs. You always have to have it in mind. Am I moving this variable? Am I moving this variable into a function? Am I storing on a stack? So that you minimize the error. Or if you get the error, then here there were suggestions. Maybe you can clone. Yeah. So note that if we try to use S after the call, take ownership, Rust will throw a compile time error. These static checks protect us from mistakes. So yeah, we can also look further at return values and scope. So this is all in ownership, and I have chosen today not to just leave it because this defines a lot of how Rust behaves. So return values and scope, and other things can be similar with other programming languages, but as long as you know how to handle scope and handle memory, then you can do it more clearly. So let me say okay, this is now clear. So fn main, okay. So if I have such, so let S1 call a function, gives ownership, because we want to look at returning values and scope. So S1 is calling this function, so that means that this function must return something. So we say that for you to return something, you should have this. This shows that the function returns a string, or it could be an integer or something. So since S1 goes to this function, let me say owned. So S1 is giving its ownership to this function, and the reason why we say it's giving its ownership because we are already dealing with strings. So we're already going to return a string. Maybe we can have another function to execute. Is to be assigned to Basecamp. So since this is independent, S2 will come into scope. And if you have later also S3, let me say take it, I'll take S2. So this means that so this comes into scope. This is stored on a heap. It is moved. It is moved to take, and then take in return moves it to S3. So this is the logic around it. You can define these functions, but I think that can be on homework. So yeah, that's how functions can also work in the same way as variables did work. Okay, so one thing I want to go to, I think for moving and not moving, we can stop here. So if we want to do with this baggage of moving strings to other things, maybe moving variables to other variables, we can do what we call referencing and borrowing. Referencing is mainly if you want to access something, you just give the reference of that. But I think before we go to reference and borrowing, we can have a short break. Okay, so we go to reference and borrowing. I think for this I'm going to create a new Rust project. So this is session 302. Main batteries. So what references do is mainly it's like a pointer in that it is an address you can follow to access the data stored at that address. But unlike a pointer, a reference is guaranteed to point to a valid value of a particular type for the life that it references that type. So this is in a way that for pointers you can have scenarios where you have a double free memory, things like that. But references will always reference to a given data, and once that data goes out of scope, then the reference will stop referencing. So that's the difference. So in that, if it is just referencing that data, then there is no need for it to move the data and to have all those things. So let's take this example. I think I can. Okay, now let me just write it. So let this one be assigned to string this is Starknet. So I want to calculate the length. I can call in a function which is called calculate length, and I reference it with this. So even in my function, I should have a string and have this reference, then return we need to return a uint. A uint is a usize is like a string. I can say let length be assigned to this dot len, and then return length. So we said yesterday that you can return like this or return in this way. When you write a return length, and then yeah, so this and this are the same thing. So now here you can say the length of the given word is the length of, maybe here I can is S1 and len. So for us to reference, we use this ampersand sign. So it's called ampersand for referencing. And the opposite of referencing is dereferencing. So we use this sign to dereference, yes. Okay, so you've seen that we have said let len equals calculate length, and we pass in the reference. So, and then when we pass in the reference, we receive the string with the reference and then return. So if you reference something, you find out that you cannot, for example, if I wanted to change this, I cannot change because it is a reference to the original value. So there are also rules that govern referencing. Okay, so we can run this program. We are not in that directory. So cd session 3 02, then cargo build or cargo run. So the length of Starknet is 8. Okay. So the way we reference is that we are just referencing to the string. We are not taking a copy of it, or we are not moving it. That means that we cannot manipulate it as well. So because S1 does not own the value it references to not be dropped when S1 stops referencing to it. The action of creating a reference is called borrowing. What happens if we modify something we are borrowing? It doesn't work. Okay, maybe we could want to, instead of calculating, we want to call a method. Let me call a method that maybe could change that. So change, let me call a function S1. So I'd love to have a function that could change S1. Be fn change this string. So if we want to change this string, we could push to the string, maybe s, so dot push string, and then Starknet, let me say Starknet Basecamp is here. So if you are pushing this, we can run the program. And we shall have an error because a reference cannot be changed. Okay, so if you want to change that, then we shall have to look for other means. Okay. So I think we have looked at some of these things. Due to the time, I think I can stop here for now. Thank you. See you in the next one. Any questions before we close?
For example, if you guys
I'd like to say thank you for today's session. It has been, a little overwhelming because I remember the assignment you gave us yesterday.
Yes.
Sorry, not yesterday, the other day. So
yes.
It felt like, like you run it and you get your degrees and it's okay. Mama. Okay, it feels like after accomplishing the assignment for the last session, it feels like, man, I have nothing.
Yeah.
Like
So
after today's class, it's like I've gone back to square one.
yeah.
But thank you so much. I am gonna go back and practice, and so I'm really grateful that there is actually a playground that we can use.
Yeah.
So it doesn't leave us out who use Windows, like you're not completely left out.
Don't worry, you will shift.
I'm working on switching to Linux.
Yeah.
Yes, but I am really, really glad that there's a playground and you can practice and practice and practice until you are, like you have the hang of it. So
Okay.
I am really, really, really grateful. Thank you so much for today's session.